Good morning, students. Today we'll start a new chapter called Surface Areas and Volumes. Now, you might have already found out the areas of various shapes like circle, triangle, rectangles. But in this chapter, we learn about finding the areas and volumes, the surface areas and volumes of 3D figures, as these earlier ones were 2D, which we call as plane figures. Now, let us move on to solid figures. Solid figures are the 3D figures. They are formed by stacking up of plane figures. For example, when we stack up rectangle over rectangle over rectangle, we get a cuboid. Now, let me just read out the definition for you. If plane figures of same shape and size are stacked up in vertical pile, we shall obtain some solid figures, briefly called as solids, such as cuboid, a cube, a cylinder. Now let us visualize this. So first we have a rectangle. We stack another rectangle, another, and similarly we keep on stacking to get this cuboid. And these are just plain figures stacked up. Now, surface area of a cuboid. Let us see how to find out the surface area. But first, let us see how many rectangles we would need if we want to cover a cuboid. Even though the answer is already given that 6 rectangular pieces are required, but let us visualize it so that you get a better understanding. So first, we would need a rectangular piece to cover the bottom of the bundle. So now we have got a rectangular piece to cover the bottom. Then we would need two long rectangular pieces of different sizes to cover the back and ends. But first we'll add up the side rectangles, that is the two long rectangular pieces to cover the two side ends. So first and second. Now then we'll need two more rectangular pieces of different sizes to cover the back and ends. So we'll add one and then two. So till now we have got one, two, we have got 1, 2, 3, 4, 5. We have got 5 faces till now. Now the last when we get the last we need is to cover the top. So we'll cover the top. Now when we open this figure, it will contain as 5 rectangles if the top is not included. Now when we cover the top, we would require another rectangular piece exactly same as the bottom one, and we'll stack it over to the top, and then we'll get 6 figures. Now since 6 rectangular figures. Now since we have opened this up, we can see that this is our bottom, this is our sides, and right B over here, this is our bottom, these are our sides, this is our front and end, and this is our top. Now, the previous exercise that we did has shown us that the outer surface of a cuboid is made up of 6 rectangles, and in fact, these faces of cuboids can be called as faces. Actually, these are called as faces. These different rectangles that we have are called as faces of the cuboid. Now we can find the surface area by multiplying and adding, that is by multiplying each face's length and breadth and finding out the area of um, a single face, and then adding all these faces areas to get the total surface area of the cuboid. Now let us move on to adding the surface areas of these all 6 faces. But first let us mark the length, breadth and height. So if we could take the length of cuboid as L, so we'll just put on these L, and then we will take breadth as B, and height would be at H. So now you see that we have got a shape with all 3 dimension length, breadth and height, which are the particulars of a 3D object. Now we'll sum over all these 6 sides. So first let us find out the area. So area of the first the first, that is, I'll just write area of 1. So area of the first face, area 1, would be length into breadth, and our breadth over here is height. So I'll just do height. We can see that it is length and it is height. So our first area have length into height, which is LH. Then area of the second face would be length into breadth. Then area of the third face would be length into height. Then area of the fourth face would be length into breadth, which is LB, LH, LB. Then area of the fifth face is equal to height into breadth, which is HB. Then we have area of the sixth and last face, this, which is again height into breadth, which is HB. Now let us add these up. When we'll add these up, LH plus LB plus LH plus HB plus H, this is B, B. So we have 1, 2, 3, 4, 5 of 1 is left. So LH, LB, LH. There is one more LB. This one is left. So we have all 6 faces. Now let us, we can see that there are like terms. So this is a like term. These two are like terms. So we just add them up. We get 2 LH. And these LB and LB. We'll get 2 LB. Then we have HB and HL was not there. It was HB. This was HB. So HB and HB. 2 HB. Now we have got this. Now let us take 2 common. 2 LH plus LB plus HB. Now we see that we have got this total surface area of a cuboid. Now here it is written in a more clear way that surface area of cuboid is this, and we have derived it how we get this surface area. Now, now to visualize it in 3D, we can see that our length is this, our breadth is this, and our height is this. The things that we have taken in previous slide, that is our length, this, the longest side kind of, but it is our choice whatever we take. So now this is our length, and in 3D this is our length. Now our base is this, so we can see that this and this would be our base, and this is our length, and our base is, and this would be our base, and our height is this. These are our heights. Now let us do the example by using, so that we can understand how to use the previous formula. So we have a cuboid whose length, breadth and height are given. We have to find its surface area. We simply know the formula. First we'll just write what is given to us. Let us write given, and we'll write length is given as 15 centimeter, breadth is given as 10 centimeter, height is given as 20 centimeters. So we have a cuboid like this. This is our cuboid with our length 15 centimeter. Height is the longest, but I'll just write it 20 centimeter. This is our height and this is our breadth. This is our height. Now we have to find its surface area, so simply add on the formula. Now our formula for surface area was 2 into L into B plus L into H plus H into B. Now 2 into L we have 15, so we multiply 15 into B is 10 plus L is 15 into H is 20 plus H is 20 into B is 10. Now 2 into 150 plus 300 plus 200, and when we add this up we get 500 plus 150, and we have 2 into 6500, 650 single zero, and which will give us 1300 centimeter square. Centimeter square because we have found out the area, and area's dimension is the square of the length's dimension. Right? So now we move on to find out the surface area of a cube. Cube is nothing very fancy, but it's just a simple cuboid, just a special cuboid, which have all the sides as equal. That is, we have our length, breadth, and height all equal. Our surface area is given as 6a squared. Now to find this surface area out, we'll use the cuboid surface area itself, because cube is itself a cuboid, just having all the sides equal. So it is a special cuboid. So let me write L into B plus B into H plus B uh, plus H into L. This was our surface area of cuboid. We have L equals to B is equals to H H, which is equals to A. Now 2 into A into A plus A into A, since B is A, H is A, plus A into A. We get 2 into A square plus B square plus, no, A square plus A square again. And we can see these are like terms, so we'll add these up, and we'll get 6A square. So this is how we have find out the area. We have derived how to find out the surface area of a cube. So we can see that it is similar to cuboid, and here we have all the sides equal. So if we have the same things, the same comparison with the cuboid one, this is our base, these are our side ends, this is our front, this is our bottom, this is our back end, and this is our top. Now, lateral surface area of cuboid and a cube. Lateral surface area means the surface area found out of a solid figure when we have not considered the top and the bottom of the figure. So in the cuboid and cube, we are not considering the top and bottom, we are only considering the walls. To consider the walls, let us find out how to derive the area. To find out the area, let us see how many faces we have. We have one face, two face, these two are same, these two are same. So area of this face is given as L into B, which is LB. Then area of this face is given as L into H, which is LH. So we'll add this up, LB plus LH, and we can easily see that here that we can easily see, okay, I have taken something wrong over here. It's not H. You can see, since we have taken this now, so it is height over here. So it is H, and then it is H. So H into B, HB, and we have L into H. So it is LH. Now we'll add these up. So we have HB plus LH. Now we know that we can see that we have two faces, so I'll just multiply 2 HP to get both of their area, and then we have L into H 2 times, so I'll just multiply 2 LH, common 2, and H is also common, so 2H L plus B. This is our lateral surface area of the cuboid or cube. To find out the lateral surface area of cube, it is the same. We only have to substitute A, B, and C. A, B, and H. So we can see that we'll derive this formula directly from the cuboid. So it was 2H L plus B. Now we have L is equals to A, B is equals to A, and height is also equal to A. So to find this, 2A and A plus A, we get 2A, 2A. So we'll multiply, we get 4A squared. And this is how we find out the lateral surface area of a cube. Now let us move on to our first example. So in this question, I'll just read this out. Mary wants to decorate her Christmas tree. She has a Christmas tree, she wants to decorate it, and she wants to place the tree on a wooden box covered with color paper with the picture of Santa Claus on it. So let me draw a wooden box. Boxes are cuboid, right? So I'll just draw a cuboid. So this would be my cuboid. And this is our wooden box. It's the line's not straight, but you get the idea, right? This is our wooden box. Now she has to cover this up with color paper, and she must know exact quantity of paper she wants to buy for this purpose. So if the wooden box has length, breadth, and height, these attributes are given. So we have length 80 centimeter, breadth is 40 centimeter, height is 20 centimeter. These things are given. So how many square sheet of side 40 centimeters she required? And a sheet that we have is squared, and it is 40 into 40. This is a square sheet. So here it looks like a rectangle. So I'll just make a square out of it. So this is a square. So we have 40, 40 into 40. All the sides are 40 centimeters. So now we have the dimensions of the wooden box, we have the dimensions of the square, of the sheet, the color sheet. So now to find this out, we have to cover this sheet, we have to cover this block up. To cover this block up, we would require the surface area, right? Because we have to cover all the faces, so we have to cover this area, that. So we'll require the surface area. So first of all, I'll just write out the surface area of the block, right? And to know how many sheets are required, we know that the area would be given as side into side. So area of the sheet has to be divided by surface area to get the number of sheets, because these sheets will cover this many area, and then one sheet would cover this much area, and other sheet would cover this much area, then this much, then this much. So that is how we make up the sheets, and we'll just consider how much area the sheets will cover. So we divide number of sheets would be equal to surface area of the block upon the area of sheet, right? So now let us perform the calculations that are to be find out. So I'll just write out over here the formula that we have formed over here. So it was number of sheets is equal to area of block, not just area but surface area of block and area of sheet. So let us find out the area of block. Length is given as 80 centimeter, breadth is given as I'll just see, breadth is given as 40 and height is given as 20. So breadth is given as 40 centimeter and height is given as 20 centimeters. So to find surface area, we'll substitute these values in the formula. We know this formula of surface area of cuboid is 2 into L into B plus B into H plus H into L. So we substitute 2 L into B means 80 into 40. Then we have B into H, that is 40 into 20. Then we have 20 into 80, which will further give us 2 into 3200 plus 800. Then we have 1600. Now we'll add these up to get 5600. Right? When we add these, we get 5600, and then when we multiply, we get 1 multiplied 2 by 56, 11200. So this is our surface area, and just write down the units, which is centimeter square of the length unit. So this is our surface area of the cuboid. Now let us find out the area of the sheet. I'll draw a partition over here. Now area of sheet It's very simple. It is a square sheet, right? It is a square sheet. 40, 40. So area is given as 40 into 40. That is side into side square, side into side, right? So 40 into 40 is given as 1600 centimeter square. Now to find the number of sheets, we'll simply just substitute these things. So number of sheets is equals to surface area of the block upon area of the sheet. So it is 11200 upon 1600. We cut the zeros out. 16 sevens is 112. So 7. So we see that number of sheets is coming out to be 7. So this is how we find out the number of sheets in the question, and this is how we find out the surface area, as we have seen by using this form. Now let us move on to our next example. Now in example number 2, Hamid has built a cubical water tank with lid for his house, with each outer edge as 1.5 meter long. That is, we have a cubical water tank. That is, this cubical means cube. Okay, we have a water tank shaped as cube, and it has a lid, and each edge is 1.5 meter long. Okay, so we can write this like this. Now he gets the outer surface of the tank, excluding the base, covered with square tiles. So he has got outer surface, that is this top, all the outer surface covered with square tiles except the base. The base is not covered. Now the square tiles are of dimension 25 into 25. Now we have to find out how much he would spend for tiles if cost of the tiles is 360 per dozen. So 1 dozen tiles cost 360. So first, to find out the cost, we need to find out how many tiles are used. Now it is similar. Now in this aspect, it is similar to the previous question. To find out the number of tiles, what we have to do is to find out the surface area of the cube, and it is not a complete surface area. We have to exclude the area of the base. So the area of the covered part, so I'll just write down this surface area of the covered part. To find number of tiles, we have to find the surface area of covered part, that is the area of cube without the base, and then we have to find out, then we have to divide it by the area of tiles. This would give us the number of tiles. Now let us proceed to finding out the surface area of the covered part. In this we already know the A is the side of the cube is given as 1.5 meter, and our side of the tiles is given as 25 centimeter. Now you can see the dimensions are different, so I'll just convert my 1.5 meter into centimeter. So 150 centimeter, which is so area is so the side is equal to 150 centimeter. Now in this cube we have I'll just draw it. In the cube we have all the sides. We do not have base. So let us find out the area first of one of the face. So area of one face would be area of one face is equals to a square, right? That is the area of a square. You already know that. Now area of one face is a square, so area of 5 face would be, we'll just simply multiply it by 5. 5a square, which is done by unitary method, right? You have already learned all these things. Since one face is a square, so 5 faces would be 5a square. So now 5 into, we have our value for area, so that is 150 square, which would give us the answer as, let us not calculate it. we can calculate it, it is nothing wrong, but if we leave it like this, it will be easier for us to cut it, since we know that we have to convert this into a fraction, because we have to find out the number of tiles. We know the formula was given as number of tiles was given as area of 5 faces, right? Because it was area excluding the base, so area of 5 face upon area of tiles, right? So this is how we have to make it. So we'll just leave it like this so that it have us easier to do the calculations. So similarly, now finding the area of tiles, we just multiply 25 into 25, since area of tiles is given as side into side because it is a square. So when we multiply it, here also we leave it like this. Let us not calculate. So it is also centimeter square, and this is also centimeter square. Now putting here these values in our formula, that is this formula, we have area of 5 faces, that is 5 into 150 into 150. I've just opened up the square, and we have 25 into 25. So this cut is 5. This is our 5, 5. Then we have 30 over here. Then we have 25. This is cut by 5. So we have 30, and then we have 5 and another cut, which will give us 6. So we have number of tiles as 180 tiles. Now you can see that without multiplying, it has become much easier to cut these up. So whenever such questions come and you have to convert these into fractions, do not simply multiply it, because it will make your calculations a little bit hard to do. So let us leave it like this, and we have the number of tiles as 180. Now it is given that 1 dozen cost 360 rupees, right? So one dozen has 12 tiles. 1 dozen always means 1 dozen is referred to as 12 number. So 12 tiles cost 360 rupees. Now one tile will cost 360 divided by 12. So we have 180 tiles. So 180 tiles would cost 360 divided by 12 into 180. And I'll just do the calculation further here. Now it is 360 divided by 12 into 180. So I'll just cut it 12, 30. Now 318, we'll get 4500 rupees. So he has spent 5400 rupees on just the tiles. So 5400 rupees are spent by Hamid on covering the water tank by tiles, and this is our final answer. So you have seen how to find out the surface area and the lateral surface area of a cube and a cuboid.